Hello. Hello, Shruthi. Thank you
Hey,
so
how's it
much.
going? How's it
Ah, it's,
going?
it's going really well. Thank you so much for coming on. I appreciate your time.
Yeah, thanks for having me.
And yeah, welcome everybody. This is our sixth episode, actually, of Ioterra Office Hours, and I'm super excited to be talking with Shruthi Soora today. And so, Shruthi, thank you so much for your time, and yeah, I'm excited for today, actually.
Yeah, me too. Thanks for having me. This is exciting and fun.
And I just want to give a couple of like pre shout outs. There's actually construction happening right next door. So I apologize for the background noises of hammers and drills. So that was unexpected today.
No worries. Same here, so you might hear the same.
All right. Awesome. Well, Shruti, yeah. So I guess I'd love to just start by just diving in a little bit, but if you're all right, I'd like to go ahead and
Sure.
just introduce you a little bit. So you're currently working at the Wireless Research Center in North Carolina, correct?
That's correct. Yep.
Okay, and WRC is awesome, and I've been back and forth with you guys over the past what I think it's like 4 years.
Yeah, almost, yeah, from the start. Yeah.
Yeah, the very beginning, and I don't think we've ever directly worked, but we've gotten to do a couple little collaborations.
Yeah.
And you guys are connected with Riot, right?
Yes, we are. They're one of our initiatives. So WRC is a nonprofit, and so our whole goal is economic development in the wireless sector. So I'm part of the engineering and testing side, where we offer services to help people who may not have RF and antenna test equipment, and we make that available instead of them spending $1 million+ on equipment that they might use, once or twice. We make that available. And then Riot is also one of our initiatives to basically help different companies collaborate and have different training workshops and such.
Awesome, and I do definitely want to touch back on Riot and touch back on WRC, but
Sure.
before then, I'd love to just ask a little bit more about you. So did you? So I know you've worked at Sony in the past,
Yep.
but is that where you started your career, or where did you start your career?
Yeah, so actually, I've worked at a couple places, or more than a couple. So I started off as an RF engineer for point-to-point radios at Harris Microwave, and they turned into Aviat Technologies in the future. Then I went to Sony Ericsson, worked on a bunch of handset um, devices, worked on the antenna design for that. Then after that, I went to a company called Greenwave Scientific, which many of you might know of Mohu, the TV antenna company. So when it was Greenwave, it was actually the DoD defense side of things. And then after I left, actually, it kind of evolved into a TV antenna company. And then after that, I went to HTC, worked in their Emerging Next Generation Technologies group, worked on a lot of really cool things. And then I afterwards moved to RF Micro Devices, which is now Corvo, working on the radio amplifier chipset side of things. And now I'm at the Wireless Research Center, so doing a lot of fun things. Every day is different, which is a blast, and helping companies, make their devices, and help it come to life.
Awesome. And so, did you study electrical engineering, or did you study RF and antenna design, like pre getting into this? It's an amazing history,
Yeah.
and you've worked with multiple companies that have so many products in the market that I know you have a ton of experience.
Yeah, so I started off with electrical and computer engineering, and then in my classes, I had a teacher that was talking about an artificial eyeball, and I thought that was the coolest thing. And he taught my electromagnetics class, and I just talked to him afterwards, and then I ended up actually doing my grad school work under him, working on antennas for artificial eyeballs. It's for people who are blind, and it essentially allows them to see. Um, and so that kind of got me kick started into the antenna world of things. And so it was just a class in school that kind of changed my life.
That's awesome. And so is that product actually like it's a thing? Like people are able to see with the eyes that are I'm very curious about this actually.
Yeah. So now it is a company, and yeah, so it's essentially it's a device that has glasses and then wirelessly connects to your eyeball that essentially helps, if for people with macular degeneration. And so what your camera sees sends the signals back to your eyeball to be able to send the signals back to your brain to say, here's what. So when I was working on it, now it's been a while, there were actually people who were completely blind who were able to, read letters and things after it was implanted. It's come a long way in the past 20 plus years, but it's it's pretty cool to be able to make a difference like that.
Yeah, no, I'm, it sounds amazing. It actually begs the question on my end, like, out of so you've been in medical type projects. I know you've done lots of consumer type products with WRC and everything, but what's been your favorite project so far?
It's
I'll say across your whole career. Like, what's been
it's
the most
hard
fun?
it's hard to pick one, but I think the cool ones have always been the ones that were kind of the unknown. Like, hey, let's be presented with a problem, and how do we solve it? And there was no real clear answer because we were actually setting the stage of how to make that answer. And I think there have been a lot of projects where you're in the process of inventing the next generation, and that's always pretty cool. So whether it's from WRC's consulting or some of my previous projects, to be able to kind of you know be able to define what comes next is a lot of fun.
Yeah, what do you I don't quite mean
Yeah.
or I don't quite understand. So it's like when someone comes to you and it's like, "Is this possible?" Is that what you mean? Or what
Yeah, so like even if you like had the example of, hey, I want to, build something that's this big into something that's this big. How do we make that happen? And you start looking at different materials, you start looking at different battery technologies, different antenna technologies, and kind of pushing the limits of every piece to be able to make that small. So yeah, it's just whether it's, a handset, when I was at the Sony Ericsson times where it's like, let's make it as thin as possible. Or if it's something, while at WRC with consulting, and, a company that's, trying to build something that's medical, or, something that's a cool tracker that has to be really small, whatever it might be, you're always kind of trying to push the envelope of, 10 years ago or 20 years ago, it would have been this big, but then you're always pushing the envelope to make it smaller and smaller. And so you end up coming up with new ideas of how to make things more efficient when you're given a hard task.
Awesome. So you brought up let's go ahead and pop this up on the screen. And yeah, let's
Yeah.
yeah, can you tell us a little bit about WRC Wireless Research Center? From what I know, it actually comes from some enterprise backgrounds too, that after kind of, what was it, the BlackBerry that or Motorola that had a huge presence and then they left the area. And then you
Y-
guys kind of
yeah.
really brought in a lot of that heavy duty RF testing equipment. Yeah, I'd love to hear
Yeah.
the story behind WRC.
Sure. So, it was actually, yeah, Sony Ericsson was a huge presence in the Raleigh-Durham area in North Carolina. And so after they shut down, a lot of the talent wanted to stick around. So the founder of WRC, Jerry Hayes, um, basically said, what can I do to help keep the talent so everybody doesn't have to move away? Because everyone, had been there for decades, or myself had, grown up there. Um, and so, he worked with the different, government bodies as well as different companies of how to get and acquire the equipment to be able to create a location where people have access to it. When you're at a large company, you have chambers and chambers, or pieces of very expensive test equipment that's easy to acquire when you're a multi-million national corporate international corporation. But if you're a one person startup, that's really difficult. And so he wanted to create a place where people have access to things that large companies do without much hassle. And so that's where he created WRC, where we have a lot of test equipment and engineering resources and software and things that people can have access to as needed. So you don't have to spend millions and millions of dollars. And then from that, there are a lot of other initiatives that have formed, but the test and engineering was the first one.
Awesome. And it is kind of this dichotomy. I mean, like, there's lots of startups building products, but, you know, what is the option? You know, they just need to hire services, right, to do this testing. You know, if they didn't have resources like WRC, I guess I'd be interested to hear a little bit about some of the kinds of companies that really utilize your
Sure.
services right now.
Yeah, so I mean, I think it depends. When you're a large corporation and maybe you don't have enough resources in house to, work on the next generation product, or or you're struggling and you need just an extra set of hands or eyes to look at it. We can help jump in to be able to say, hey, I can get you from passing, from failing, sorry, failing something or something not working to the point of passing, or like a one person startup that RF and antenna engineering is a very specialized field. And so with that, you may not need one person on staff the whole time, and you may want to spread your resources internal to your company to other areas like software or hardware that might be needed throughout. So we tend to jump in as needed, so we can kind of jump in at the beginning of the product and at different points of the design cycle to help, whether you're using the test equipment or our engineering resources, and then help guide through the way, but we're not a full-time you know um, participant so in the company. So we can essentially, it's a consulting firm, um, and so we help companies big and small. We've had, especially with IoT, a lot of sectors that are not related to wireless. Traditionally the old, wireless companies were more, government based or, telecom based. But now you've got, let's say, a medical company that's really, its focus is chemistry. They don't really want to focus on antennas and wireless, and they need our help to help jump in and let them focus on what they're strong at, and we can help support them to make it something that's IoT based.
Yeah, no, that makes a lot of sense. And the applications around IoT are obviously numerous and things, but it is cool that there's, I think now more than ever, the need to specialize is prevalent. And when companies do specialize, you get things like WRC where
Yeah,
I don't have to spend, if I'm trying to develop my new, state of the art sensor, I don't have to spend all of the time and money to kind of build that up. You can work with partners. I guess I'd be kind of curious, around now, like getting a little more technical into antenna design. Like what
sure.
is actually required, and what's the difference between like a system on a chip that has some kind of built-in antenna, or on the module that has an antenna, and like what goes into kind of the design decisions.
Sure.
Yeah,
Yeah, so I mean, there are a lot of options that have a lot of the pieces already, completed for you. And we actually recommend, if there's something that's already done, why reinvent the wheel? Try to build upon it. And so there are a lot of great modules that have antennas built in or off the shelf antennas that are, you can buy off, a distributor and plug into your device. The key is that they're always, a lot of times, unlike like a surface mount component on a PCB, like an inductor or capacitor, it's not so easily plug and play. And so antennas are really, really sensitive to the environment. One example is if you put your hand on your phone, you might see the signal strength change the second you're rubbing your pinky on it, whether you put it on a metal table, all of those things change the performance of the antenna. In the same way, if you buy, let's say a sticky, a flexible adhesive antenna, and you adhere it inside your device, where it's placed, how it's implemented, all impact the antenna performance. And so those are things that we help people, figure out what's the right part to choose, where's the right place to place it, and even if it's on a module. how to correctly implement that. So a lot of times antennas are really impacted by the whole system. So we try to make sure that what it looks like on the data sheet is actually what you're going to hopefully get close to achieving in your actual final product. And so we help you make sure that it's built in the right way. So it's you're not taking an antenna and then just covering it up with a metal box where it doesn't actually work. And at the end, you want happy customers.
Yeah. Okay. So
Yeah.
the questions are just piling up in my head. I'm going to try to keep them here, but two of them. One, I'd love to hear about some of the equipment that is used to actually test, but then also maybe
Sure.
design antennas. And then I want to hear some horror stories if you have any, like around stuff that's gone wrong. And that'd be kind of fun, actually.
So as far as the equipment, some of them are, are different types of benchtop equipment to be able to check a vector network analyzers, spectrum analyzers, um, signal sources, things like that, to be able to actually see, RF wise, how well, what frequency is it operating and how well is it transmitting. Shield rooms, basically, to be able to test in an environment where you're not getting your neighbor's Wi-Fi interfering. If you're going to try to test a Wi-Fi device, you need to be in a controlled environment. So we have a lot of shield rooms and anechoic rooms that basically allow for a controlled test setup. And then the coolest one is our antenna test chamber. And it's actually a CTI certified chamber. And we can actually fit things up to 6 feet or even sometimes larger in there. So if you were trying to, let's say, test a wireless refrigerator, you could actually test how well the antenna performs on something that big. Or we actually have human body phantoms. So if you had, like, let's say, an ankle device, we can actually put an actual human or our fake human, because actual humans don't like to stand still inside an antenna chamber in the dark.
Yeah.
So we use our human body phantom for long testing. But essentially, the antenna chamber is a cool arch, and you have a mast, and essentially it measures how well the antenna radiates in a 3D spherical shape. So is it pointing up? Is it pointing to the sides? Is it omnidirectional? And that all impacts how well your device will perform. And then another cool piece of test equipment, especially with 5G coming up, is portable towers. So we actually have portable towers that we can wheel out to different locations. And as you get into 5G and millimeter wave, even like trees can impact the performance, whether it's fall versus spring versus winter. The leaves, the trees, the snow, the ice, all of that can impact how well those high frequency waves will propagate through from the base station to your device. And so we actually have these towers to be able to measure, and so they can, drive and set up, and they shoot up 106 feet. And we can put
Wow.
different pieces of test equipment there, or fly a drone near it, or things of that sort, to see how well. So we're set up for a lot of different scenarios, whether it's just antenna or system or network design. And sorry, what was the second question?
I just like stories where antenna problems have kind of gone wrong or perpetuated or compounded. Like what a lot of people don't think of antenna design as that important early on, or at least people like me. Like as we start building, and trying to get products out in the market, and a lot of I've been a part of consumer product development initiatives that have had some major problems that came far on into the development due to just like not looking at it early enough. I just like to hear some of those.
Yeah, I mean, I think the most heartbreaking ones are when a customer comes and they're like ready to launch, and they're like, "Oh, we haven't tested antenna performance. Let me check it." And then they test it and it's failing. And it's hard because antennas are not just a simple thing that you can just change by just, changing a component. They usually require tooling changes or PCB changes, or something more drastic. So it's always important to start as early as possible, even when it's just an idea in your head, to work on it. And so I think the hardest ones are when it's late in the game and you want to be able to fix it, and you're trying to come up with some sort of easy quick solution that may not fix, the entire system the way you want it to, but just trying to, let it get to the best of its ability within that structure. Or they have to delay their schedule, add more budget to be able to do a respin of the board. Then, they're not launching in December, they're launching in the summer, and it just changes their whole schedule. And it's hard because it's like, oh, if we could have tested this 1 hour test, 6 months ago, we could have, prevented a lot of heartache later on. So I think those are always the hardest ones, and the most challenging, because it's when, especially when it's a startup, you want to see them succeed, especially the nonprofit nature of the way we are. We want to see companies succeed. And so, usually the next time we'll start from the beginning on the next version.
Yeah.
But I think that's the hardest. I mean, some of them, it's always nice to be able to see, if companies have added design hooks, or we've been involved in the start where there has been, something that failed, and it's like, oh yeah, all we have to do is just make a bomb change, and then, it's quick and easy. And so it's you see a lot of extremes, as far as challenges of hard antennas. But um, sometimes if people put things inside a metal box, it doesn't tend to radiate. But, sometimes cool cutouts can help too. So it's looking at the whole system of how it works, how it's intended to be used, and then trying to engineer and optimize from there. Hopefully that answered your question.
Definitely, definitely. No, I mean, that's the danger, and you said at the idea stage, so that's earlier than I was even thinking. Yeah, it's just good to think about, like, okay, is this going to have problems? How are we going to just early
Yeah.
on, put something into place that could solve a lot of problems down the line? Probably more so for very small devices than large devices where you have more wiggle room.
Yeah, it's a little bit of both. Yeah, so yeah, thinking about it at the early stages, and kind of always thinking about how it's always going to be used at the end. That's one thing that's often overlooked. People are always trying to just meet the specs, which often are, what's written on paper. And those test scenarios, as far as like the regulatory, like FCC or carrier requirements, are tested in a standard way. But at the end, let's say if you've got like, I don't know, like a little tracking device, right? How it's actually tested in certification might just be on, in free space just by itself. But in real life, it might be, you know, um, on your waist, or it might be, inside your car or whatever. So trying to understand how it's used, and making sure you optimize at the end that your customer is happy, um, and not returning things, is something that's often overlooked. So we try to make sure that you make your customers happy, as well as your, the certification bodies happy
Yeah.
too.
Yeah,
Yeah.
it's like I remember one project that was, it was such a bummer, but basically it was a wristwatch, Bluetooth, pretty
Yeah.
normal thing, but they wanted to make it ultra waterproof, and they ended up potting it, or deciding to pot it, and that
Yep.
basically, just that, like, tanked their antenna performance, and then their wristwatch was like barely able to connect to your phone, like 3 feet away.
Yeah. Yeah.
And then it was a
Yeah.
whole entire, like, big thing, because it was being marketed as this very waterproof device, and so they had to redo mechanicals and all kinds of stuff until I figured this out.
Yeah, yeah, we often see things just like that. That it looks, it's great from like the marketing and end goal style side. And it's not that it's not possible, it's just you have to kind of work at it as a system to figure out how to make it possible. Um and
Yeah.
yeah.
Well, okay, a couple more questions. I'd like I've been hearing a lot about the new bandwidths, or bandwaves that are now available for, like, private cellular and stuff like that. Do you guys have any? You've done any work with some of that lately?
Like the 5G stuff, or
Yeah, the 5G stuff, but
yeah.
also, like, the ability to make private networks
Yep.
for like, yeah, companies and things that are not connected to, yeah, AT&T or Verizon or.
Yeah, yeah. So I mean, we have other team members that work on more on the architecture and network side of the whole protocol stack. So we have actually some initiatives within WRC of trying to build like a test bed for 5G drones, and making being able to use networks to be able to figure out kind of what can drones do next, and whether it's a private or public network. So yeah, we're involved with customers that are like, hey, I want to build this private network, but I don't know what to do next. And we have some specialists that actually help figure out what's needed, figure out the architecture, figure out um, all the fine details of how to make that possible. Thinking in now the generation of now, as well as what's going to come, to make it as versatile as possible. Um,
Awesome. Yeah. And then, okay, so nonprofit, WRC nonprofit, that's a unusual thing for an antenna an antenna company and an antenna testing and design. Yeah, can you talk a little bit about that? And then like I'd like to bridge that into Riot, and because Riot's super cool and we're just starting to get involved with you guys, but would love to hear a little bit about that as well.
Sure, sure. So yeah, so as far as the nonprofit nature, the part of the nonprofit side is just to be able to see people grow, companies grow, and so with that we remain neutral. So like with that, there might be certain vendors. We like to explore all vendors. So if we're working with a customer, we're not going to be you know geared towards always use this solution. We're going to make sure that we pick the right solution for you by maintaining a neutral stance, and evaluating it everything in a um in a way that we can compare and see what's best for each application. um, and then as far as on the nonprofit nature, we have so I'm on the engineering and test side, but there are other initiatives. We have one that's called Connected Communities, of being able to how to get broadband access towards for all people in all areas. And then Riot is another one. And so Riot is an organization within WRC that has different events, different workshops, educational um, sessions, where there's something called the WRAP program, where basically it's a 12-week free workshop for startups to join. You apply, and if you get in, you basically learn all the way from technology to invest, getting VCs and business plans, and basically the ins and outs of how to develop an IoT company from ground up. You get a lot of connections. There are a lot of different events and conferences and things of that sort, both virtual and in person, and a lot of outreach towards the community, with on the educational side, government side, and private and sector side of things too. So there's a lot of activities, and it's a great division within WRC.
Awesome. And yeah, so in terms of um, the future, I guess, yeah, with like the type of work that you're doing right now, and so you said you've been solidly in the engineering space for quite some
Yep.
time now. So you'll work with both companies from maybe within Riot type programs, as well as a lot of outside startups, a lot of outside large organizations that are coming in. And as you mentioned, there's different ways of working with you. Yeah, what's happening? What's going to be new for WRC over the next couple of years?
Well, we're hoping we're jumping into the 5G world of things, and then there's a lot of just cool technologies with things getting smaller and more energy efficient, and just making our lives easier. So it with that, there's a lot of interesting things of how do you um, use wireless and antennas to help predict stuff, whether whatever it might be. um, and so, with higher frequencies, especially with 5G, it opens up a lot of doors of being able to do, um, things that were not possible before. Being able to use frequencies all the way from low megahertz all the way to millimeter wave frequencies gives a lot of open-ended opportunities to do something that's, how do you talk to things within the body, or how do you talk to things, and really send a high data throughput signal, across the room, or across, the park or whatever. Drones are a really cool thing. That we're seeing a lot with how do you use drones and UAVs to be able to make our lives easier, as far as helping, whether it's providing internet access to different places, or whether it's for emergency types of usage. So they're just it seems like the doors are opening for so many different applications, and IoT is all part of it, right? So when wireless, a lot of times people overlook the wireless part of it, and our founder kind of says it's a lot of times it's like the plumbing, like it's all good when it's working, but then the second it stops working, that's all you can think of. and so we try to make sure that the wireless side of things it's always working, so you never have to think about it, and it's just part of your daily life. And the second that your device doesn't connect, that's when you start thinking about it, so we try to prevent that.
Yeah. Yeah, and it seems to change so fast still. It's like almost every year, things are getting better, or new stuff is coming out. Like, I guess, where are you excited about the field in general? So 5G is interesting, and
Yeah.
things happening there. But what are some of the, like, the biggest game changers that you've seen, and perpetuating that out a bit? Like, where are we going with the with the next phase of wireless?
I think it's just, I mean, and it's all part of kind of the bigger IoT space, but just kind of everything being connected to be able to, from, being able to prevent issues from happening, being by using sensors, and by using, um, kind of the whole Internet of Things, data, um, whether it's, if you have, let's say like an accident down the street, being able to be preventative, whether it's, the first responders are right there right away, and how to get them there faster, or if it's, how could you, even prevent that accident from happening in the first place by, sensors on a car, or sensors on the pedestrians, or things of that sort, or smart, cities and things. So I think it's just, making the world a safer and and better place. I think is pretty cool. So there are a lot of different applications, and it's always exciting to see our customers come to us with, hey, I need help with X, Y, or Z. And it's like, oh, that's a great idea. And you start thinking about how I could use this, every day.
Yeah.
And you're excited, it's exciting to be part of that. Yeah.
Yeah. And on the tech side, have you seen big changes in, like, the tools that you're using to analyze things, or has that been pretty relatively consistent? Because,
No, I
yeah,
mean,
I'm curious.
computing power actually helps a lot. So you can get, when I first started in the industry, running a simulation took a long, long time. And so to be able to do things even prior to the parts being built, that early stage concept was really difficult. Now, with just the computers the way they are, you have a lot of memory, you have a lot of simulation tools where we can run parametric sweeps, overnight, and basically say, okay, well, if I made my device, if someone was looking at a rectangle, if I said, okay, well, I ran some sweeps overnight and said, okay, if this rectangle had this tapered edge, and was this dimension, and that gets you better performance, let's say 45 millimeters instead of 50, and that gets your performance up by 20%, that allows me to, you know do have the computer do work while I'm sleeping, and
Yeah.
help become, more efficient in the antenna design. um, and so it's, I think, it's just nice to be able to see how technology is just keeps evolving and allows us to, utilize it in a smarter way.
That's awesome, and that's crazy. I like what
Yeah.
you just said. Actually, kind of blows my mind. Like something like a chamfered edge or something can actually increase performance by like 20%.
Well,
Is
it's
that
just
is that
it's
or is that like or
I mean,
yeah, that's crazy. It's awesome. Yeah.
yeah, I mean, it depends on how it's the shape of the chamfered edge and how far away it is from things. But you can use simulations basically to throw out different ideas and brainstorm. Um, and say, hey, if I made, place things in this location, slide the speaker, x number of millimeters to the right, and move the screw to the left, or if I connect to the screw, I can make it a little better. So being able to use the EM simulation tools along with 3D printing is actually really helpful too, because then you can actually build something and test it out immediately.
Mhm.
So kind of those two hand in hand, I think, you know in the past decade have helped a lot.
So I asked, that's really cool. Yeah, sorry, I'm pretty fascinated by this field of study, the black magic RF. Yeah, but so I asked you about the horror story. Can you give me like a successful case study that's no company names or anything, but just like what happened? What was a cool thing?
Yeah, I mean, I'm trying to think. There've been I'm trying to think of one of the best ones. Um, so, I mean, I think it's we had some companies that were trying to they had some ideas on paper, and came to us at the early stage, and said, we need some help, and they started off with they wanted our help on just one subsystem, and we started working on it, and they were happy, and they were like, oh, well, can you help us with this other thing? And they had a big deadline in, like, 6 months. So for that time period, we were working with them, and they saw how versatile we were as far as testing and engineering. And they had their customer, who was supposed to come visit, and they actually ended up having the customer come visit our test facility. And they basically had their entire, like, manufacturing line set up in our facility to be able to build and then test, and then we could optimize and help them with the support. So it was cool because we could essentially integrate and act as an extension of their team and help them succeed, all the way from building it, testing it, optimizing it, engineering, all the way from the radio side of things as well as the antenna. And so it was pretty cool to kind of be integrated into their ecosystem to the point where they actually had their customer there on site too, to be able to see it built and tested real time. And then if
Awesome.
so that was pretty cool.
Awesome. And so you just mentioned one thing that in my mind, I don't know why I do this, but I've just always associated antenna with radio, and it's like the same entity in my mind. Can you, because you just mentioned radio antenna, like, can you just explain a little bit there what's going on?
Yeah. So I guess in my head they're very intertwined but still different. So the radio is what's on the board, and that has to output or a certain power or receive a certain signal, whatever frequency or modulation it might be. And that's usually tends to be on the board, or a subsystem of its own, and it has certain requirements. The antenna tends to be kind of more integrated into the overall structure, whether it's in a wristband or wristwatch, or if it's on the top of a vehicle or a truck or something like that. And so they have different requirements, different ways of testing, but they have to be, the antenna designer and the radio designer need to always be in constant communication, because you could have the radio outputting the greatest thing in the world, but if the antenna is really bad, the whole system won't see anything. Or vice versa. If the antenna is really great, but the radio is not, you know, um, optimized to the full extent, then you may not see anything as well either. So it's still something that you have to work together as a system, but kind of different schools of thought, different test equipment pieces that you use for each one as well. So there are different strategies of testing a radio versus antenna.
Hmm. And at WRC, do you guys have people that are kind of specialized in those different areas, or are you really focused on antenna design?
No,
And
we work on both. So a lot of times, a lot of the systems issues that we see, are very intertwined with antenna and radio, and a lot of times even things like power supplies or batteries or displays or things like that too. So yeah, so we work on both the radio and the antenna side of things, and but have different sets of software tools, test equipment tools, um, and such to help optimize each one.
awesome. And we're kind of running close on time, but I wanted to ask a couple more. Just
Sure.
because you're in the wireless space, so so solidly, like the classic. What are you seeing the most of question? There's NB-IoT, LoRa, Wi-Fi, cellular, Bluetooth. The whole shebang. RFID. What are you seeing a lot of nowadays?
Um, Most recently, I think a lot of people are trying to get into the more lower power, and so a lot of Cat-M1 narrowband IoT devices, which present its own challenge because they want to be super small, super battery life efficient, and used in all sorts of different types of applications, which makes it very interesting. We're also seeing a lot with just kind of UAV drone type applications too, medical and wearable. I think just as things get smaller, we're starting to see people wanting to the batteries making battery life getting better allows for more applications too. But I think um, and of course 5G. Everyone wants to jump into the 5G, and so we're happy to support that. And we've been helping people depending on which portion of 5G, whether it's the low frequency or high frequency, and kind of a lot of systems kind of how do I build a whole network architecture and kind of more than just the antenna, but how does the whole system work together? So we've been helping with a lot of that too.
Awesome. And I guess yeah, it is cool to see the variety of different, like, necessary elements. Like, oh, I'm sorry about the noise, but
No
when it
worries.
comes to like a drone, for instance, it has to maintain a super solid connection or it's going to crash for like what,
Yep.
like half a mile or sometimes more than that. That's pretty crazy and interesting to see those kinds of use cases that come on tiny little packages.
Yeah, yeah. So
Yeah,
yeah, I think each application, it's always interesting to see what pops up next, and kind of the challenges that go about that, but also trying to figure out how to get past that too.
yeah. Well, hey, I really appreciate your time.
Yeah,
And yeah,
thanks for
yeah,
having me.
yeah. No, thanks for it's a fascinating speaking with you. And I really do want to yeah, promote WRC. So for anyone who watches this down the line, like check out wrc-nc.org, and also Riot. And yeah, you might get to work with Shruthi. It'd be
Looking
awesome.
forward to it. Yeah.
Awesome. Well, hey, thank you so much. I'm going to go ahead and play the outro, and have a great rest of the week.
All right, thank you. You too. See ya.
All right. Great. Go ahead and and
Check it out.